And this next question is saying, what would the expected price be for this stock if the growth rate was equal to 0? Well, that would make this a perpetuity because we'd have R minus G, but G would be 0. So we just have the next expected dividend, which if it's not growing by any amount, it's always going to be $2. And so if we just take $2 divided by the rate, that is the definition for a perpetuity in terms of calculating the intrinsic value. And so you get $15.38. So if you ever see something like this, just know it's a even more simple equation to calculate. And then we have the situation is, what if we have, well, they call it supernormal growth, but like a really high growth rate for a certain period of time, and then a long run growth rate we can assume for all of the time periods after that. So we use the constant growth model equation for part of solving this question, but we have to do a lot more work to answer this question. It would really be better if we could solve this in Excel because it would make it easier, but we're going to solve this by hand, so we'll look at how we do this. So 30% growth for 3 years and then 6% growth thereafter. And the reason why a company might have this super high growth in the first 3 years is it could be a startup company where the growth is really high at first. So this looks really complicated, but if you just start from the beginning, you had the dividend of $2 that occurred at time 0, and this doesn't go into the calculation of the present value of the stock. I didn't mention this before, but this has already been paid, so it just doesn't go into any calculation. The only things that go into the calculation of a stock's intrinsic value is future cash flows. So let's assume that it grows at 30% for 3 years. So if I increase $2 by 30%, the expected dividend at year 1 is $2.60. And then I increase that by 30%, we get $3.38. And then if I increase that by 30%, I get $4.39. So this part, we just have to find the present value of each one of these cash flows. And so you can see that they did that with these first 3 numbers down here. But that's just for the next 3 years. We need to find what's the value of the dividends growing at 6% after year 3 forever. So remember, if we wanted to find the value of something like at time 3, which is the case for this problem, we need D4 over R minus G, and we're still using this constant growth model here. So I need to go ahead and get D4, which is where I multiply $4.39 by 1.06 using this new second constant growth rate, and I get 4.658. So that is the D4 divided by R minus G, and keep in mind that now the G is 6%. It's the long run constant growth rate. And so the value of everything after year 3 in time $3 is $66.54. Now that's not a present value, it's a time 3 present value. So we need to discount the $66.54 all the way back to time 0, or today's dollar values. And so once you have these numbers, you can sum them up and find the price of the stock today. If you would like another way to do this problem, then you can use your financial calculator. And this is really the way that I would do it. So if you've got your cash flows at time 1, 2, and 3 consists of these 2 cash flows, you can enter this into the cash flow register. So if I click on the cash flow register, I want to hit second, clear work, to clear out any other cash flows that might be there. And then I'll leave cash flow 0 at 0, so I'll hit the down arrow. And cash flow 1 would be $2.60. And remember, I hit enter to make it stay there and hit down. leave frequency alone, go down. Cash flow 2 is 3.38, and then I hit enter and down and go to cash flow 3. And cash flow 3 is going to be the sum of $4 and 4.394 plus 66.54, these two numbers. And when I sum those, it's 70.934, and that's because those two cash flows occur at the same time, so we need to sum them. Hit enter, and then I'm done entering my cash flows, so I go to net present value. I is the discount rate, and that's the required rate of return on the stock, which is 13%. So I hit 13 and enter and hit the down arrow and hit compute. And you can see that I get the same thing, the $54.11, just like I got here with the long method. So just keep that in mind if you wanted to use the cash flow register. Now let's look at that supernormal growth example, the dividend yield and the capital gains yield during the first year versus the dividend yield and capital gains during the fourth year. So in the first year, you can see that if you took D1 divided by the price that we calculated, you'd get a dividend yield of 4.81%, which was different than the 7% that we had before. And then the capital gains yield was larger, whereas before it was 6%, and because of the supernormal growth period, it's actually 8.19. And the reason, or how they got that, was they took the required return and this subtracted the dividend yield like we talked about. And so you can see that in the early years for the supernormal growth type stock, the dividend yield will be lower relative to the capital gains yield compared to if it was a constant growth stock. So during those non-constant growth years, the dividend yield and capital gains yield they're going to be changing over time. But once it gets to after time 3, then the stock will have a constant growth and dividend yield of 7%, while the capital gains yield then at that point will be 6%. So the dividend yield will be 7%, and the capital gains yield of 6% is equal to that constant growth rate. So whenever you have a constant growth rate stock, you can say the capital gains yield is equal to G, the growth rate. But that's only when it's the constant growth rate. So now let's look at an example if the growth rate is 0% for 3 years for some odd reason, and then you get a constant growth rate of 6%. What would the price be for this type of stock? And so you're going to have a $2 dividend, and then at time 4 you need to find that D4 so we can get the present value at time 3 for all the dividends that occur after time 3. So D4 is $2 times 1.06, this growth rate, and you get $2.12, and you divide that by R minus G. And so the present value of everything after time 3 is $30.29. But remember, this is at time 3. So we have to discount that $30.29 back to the present, just like we discount each of these dividend payments, years 1 through 3, back to the present. And if you sum those present values, you get a price of $25.72. If you wanted to see how to solve this in the calculator, then we would just enter the cash flows, go to the cash flow register, and I need to hit second clear work to clear out the previous problem that I worked. And I need to enter in cash flow 0 is 0, hit the down arrow key, and then cash flow 1 was 2, cash flow 2 was 2, and cash flow 3 is 2 plus the $30.29. So 32.29 and enter. And then I go to the NPV, and my discount rate is the same, 13%. And so I hit 13 and enter, and I hit the down arrow, and then it's telling me to compute. So I hit compute, and I get the $25.72 or 71 cents, which is the same thing that they got here. So anyways, I think the calculator method is much more quick. Um, it's a quicker method to use. So now we could look at the capital gains and dividend yields during the first and fourth years for this problem that we just did. And so the dividend yield was $2 divided by the price, so 7.78. And the capital gains yield, if we subtracted 7.78 from the required return of 13%, we get 5.22%. And then, so we know that just like before, the dividend yield and capital gains yield, well, actually, they will be the same for the first 3 years at the 7.78 and the 5.22, since that dividend stays at the same dollar amount. And then at year 3, after year 3, when it becomes that constant growth rate stock, the dividend yield will go to 7% and the capital gains yield will go to the constant growth rate of 6%. Now, what about if we had a stock with a negative growth? Would there be any value to this kind of stock? Well, the company is earning something and paying some dividends, so it clearly has a value greater than 0. And then we can find that value using the constant growth model. So we have D1 over RS minus G, and so the growth rate is negative 6%. So since I don't have D1 and I have this negative growth rate, I have to use the D0 times 1 plus G because we have a negative situation here. And so that's $2 times 1 plus negative 0.06. So that means it's less than 1, 0.94. And so we get 1.88 as the next expected dividend because it has that negative growth rate. It's like having a dividend cut for the next year. And then in the denominator, we'll take the required return of 13% minus a negative growth rate of 6%. So a minus times a minus is a plus, and so we get 0.19 in the denominator. And then when we divide that, we get a stock price of $9.89. So the dividend and capital gains yields will remain constant over time, but a high 19% dividend yield is needed to offset the negative capital gains yield. And that's what you see here. So if the capital gains yield is going to be constant at negative 6, then we say RS, required return minus the growth rate, that's going to equal 19%. And just keep in mind that these are just lots of kind of weird different examples to go through just to show you how different things affect the capital gains yield and the dividend yield. It doesn't mean that all the stocks that you encounter are going to look like some of these.